Hello, everyone. Welcome to Bootcamp. In today's session, we'll be doing some new things. We'll be discussing modern applications, Jamstack, and a lot of the related technologies that go into it. Ziasab, do you want to get started?
Yes, just a second. Okay. What we are going to do is everybody has their own view. Modern application development is so new that everybody has their own take on it. I've been researching for this for the last 2-3 months. Therefore, I think I've got a hang of it, and I assuming that all three of you understand it a little bit, because I understand, I think, about 60% of it. And what we are going to do is, I'm going to ask a question, and then we'll do is go by one, and everybody will give their own response, and in the end, I'll sum it up. Is that okay, brothers?
Yeah.
Sure, sir.
Yes.
Okay. Okay. What we are going to do is the first question. The last time, Daniel, we were developing software, Zeeshan. The last time we were developing software, we were developing, of course, Angular. The last time, I mean about 2-3 years back. We had an Angular front end or a React front end, which in case of React, I'm going to talk to React because most of our students know React very well. So therefore, they were developing applications in Create React app. And basically, it was a MERN stack. That Create React app used to talk to Express server, Node.js Express server, and that was talking to MongoDB. So that was MERN MERN stack most of the time. Of course, when we started off, Zeeshan, we were on mean stack.
Yes.
We were developing.
It's same, just a difference between the Angular and React.
And before that, we were doing the same thing, but on the server side, we were doing Java or .NET.
Yeah. Yes.
But the client side was the same. Of course, in the beginning, we were not using Angular, but we were just using JavaScript applications. But the point is, it was, now they are calling it monolithic apps. Of course, at that time, we did not realize it. Now they are saying, the industry is saying that instead of monolithic apps, you should develop modern apps. Adil, what is your take on it? What is wrong with the monolithic app, and what are modern apps?
Okay. Yeah. So monolithic apps would be something that's very tightly coupled, and it includes the backend, the front end, all the services in between. So it's all like a one big package, and it becomes harder to maybe update your application. It becomes harder to do more innovation in your application. If you make a small change in one feature, for example, you'll have to run testing on the entire application because it's all one big box. As opposed to a more modern application is what this is being called. It's something that's more loosely coupled. So the idea is that as everything is switching towards this more idea of innovation and building in increments and working with this agile methodology, so organizations, they're trying to build applications faster, and that they want to be able to scale them quicker, and they're supposed to be quick in responding to the users as well. So with this approach, we're using separating out the front end from the back end, and we'll get into the serverless side of it, where the back end is actually on serverless, so you don't even have to worry about having a infrastructure and scaling the infrastructure, where you let the service providers such as Amazon or Netlify or Versal scale the serverless framework, and you focus more on the user experience and the front end side of it and the API services.
Your mic is off.
Daniel, what do you think?
Yes, sir. As Adil bhai explained, definitely. In monolithic application, we have so many problems because if when I started the development, I still remember one of my client, I built the application that was a management application, and 6 months I did some work on monolithic application architecture. As Adil bhai explained, monolithic application architecture is we have all the code in one uh, code base, in one file, or in just multiple files, but it is all dependent with other features. If we have multiple features, let's suppose we have a management application, in the management application we have multiple features, and in according to the monolithic application we have all features is dependent on others. Let's suppose later on my client said we need some some specific features out, and we need to build in another project that has another project of same client, so we stuck at that point. So the architecture is very very important for the application. I will suggest to all the students, you can spend a lot of time on architecture before building any application. If you are if you want to take more than 1 week, 2 weeks, 3 weeks, or month, first create the architecture. Let's suppose I always give the example of Facebook. We have a Facebook application. The architecture, if you just see the application of Facebook, there is we have a messenger in web application, same as we have the mobile specific messenger. So if we have the um, if we have a monolithic application, so we cannot manage that messenger in mobile app and in web app. So this architecture is very important.
Zeeshan.
Uh, Basically, mainly, if you try to understand the monolithic application, as both of Adil and Daniel explained, that we have a client and a server. Previously, there is another step in monolithic application, but previously the client side and the server side and interactivity with database was in single application. So if you made a change only for the UI, even then you have to deploy a full application. If you change a single line in a server code, you need to deploy complete application with client and the server both, because everything was in a one single package. The second stage was when we were creating a client application separate and a server application as a separate application. There will be two applications, like we do in React and in case of mean and MERN stack. So what was that? And in that case, we deploy client application separately and a server application separately. Even then, server has all the features in single code base. So if I want to change a single use case, I want to add a new feature, I want to update a feature, then I have to deploy the complete server again. If I try to update the UI, then I have to deploy the complete UI again. But in case of UI, we definitely need to deploy complete UI again. The main difference is the server, because we have a server. Let's say we deploy in even maybe in JavaScript, in Node.js, or in Java, or in any client server side framework. So we build the application with all the features inside it, and we deploy that server, and then whatever change we require, we need to update that server completely. That's where the concept of what you say modern application or a serverless servers, the concepts are what you say. Today we are discussing modern application, but this modern application is a concept combination of many other concepts which released step by step. Let's say the one we are talking about, the serverless, it was introduced by the AWS in maybe around 2013 or 14, And the concept was that you do not need to focus or do not need to focus on infrastructure, just focus on your particular feature. So you write a code as a separate function and deploy it. So if you have a 10 or 20 or 30 use cases, you deploy 10, 30 functions that are separately. Now you need to add one more function. Just add that function. You don't need to deploy or update anything else. If you want to update a function, that will be a single function. You don't need to update or deploy anything else. In that case, your server become what you say serverless. It has a server, but we do not need to manage it, because any serverless application, in case of AWS, Netlify, or any other, they are managing that server. So from the client, we are calling the APIs, and those APIs will reach to the server, which is in Lambda servers or in serverless functions, and we access them. There is another thing which was in current modern application. We are discussing that we should have a database also as or what you say, you can directly call the database from the client, as we will discuss in I guess in moving forward. But previously, I guess maybe same again in 2014 or 15 or 13, when MongoDB was introduced or NoSQL database was introduced, there was a service which helps you can call directly database query from the client side. I'm forgetting the name of the service that was very common, and we were using it, and Facebook bought it and deprecated, destroyed. Facebook buy that product and then deprecated that product, closed it down. So, but at that time, what we had is, it was so fast that you can directly contact the database, just like we do today with the Firebase. We call from the client side, we call the Firebase. So in modern application, we have a client side, a separate client side. We have a server with the what you say separate functions or a small microservices. A better terminology is microservices. So you develop a microservices instead of create a complete monolithic application with all the function inside it. So you create small functions, small services, which is called microservices, and your application contact to them, and then you contact to the database. There are more to it, but we'll discuss moving on.
Okay, Adil, could you please open the website so that I can look up the, I have it on mine, but share it on the screen, modern application definition, because yes. I want to go over line by line and discuss it.
Sure. Okay. You want to come to, you want to open the AWS?
Just before that. Yes.
Oh, this one. Okay.
And could you, yes, could you little bit, it is basically cut. Yeah, that's perfect. Now, first thing, the first question that arises is, why were people using monolithic, why were people building monolithic applications in the first place? And the reason was because all the code was connected, and in one place it was easier to develop. Because a single developer, a full stack developer, or maybe 2-3 developers, could basically develop both the client side and the server side. Initially, actually the client side, when there were days of PHP and ASP.NET, and there was no APIs, and before Ajax came into being, we were basically developing client side on the server with templates. And of course, then Ajax came into being, and then we started Ajax applications were basically a lot of code when JavaScript went on the client side, but still everything, the Node.js application, that's why people loved developing in Node.js and Express, because the client side you need Java, you need JavaScript, on the server side you need JavaScript, and even in MongoDB was basically document-oriented database with basically JSON type of rows or documents, to be more exact. Now, that was the reason it was much easier to develop. But the problem was, they are extremely difficult to scale. Monolithic applications are very difficult to scale. When I mean very difficult to scale, I mean that if you want to scale it, let's say to 1 million users, just forget about it in monolithic applications, it will become very difficult. And so therefore, if you want to be scaled, you want to have for example, if you want to build something like Uber or Facebook apps in the old days, it was tough going. It took us millions of dollars of infrastructure. You had to have the infrastructure as well as the architecture in place. And it was very difficult to scale. Everybody knows Twitter's dilemma in the beginning. They used to have a fail bill every few hours. Maybe I'm exaggerating, but a little bit, but every few days it was common. Twitter used to fail every few days. Now, we are in a new age. Now, let's see. What are these modern applications? Modern applications are built with a combination of modular architecture patterns like microservices instead of monolithic and components. Number one point. In the modern applications, you develop everything as modules. On the client side, as React or other components, web components, and on the server side, microservices. It has a serverless operational model. Now, what is this serverless? We will discuss it later, but right now, making it very short, serverless operational models means that if you do not worry about the server, if nothing is running, you are not charged anything, it is in the cloud. If you run one application, one function, you will be charged for one function, maybe for 20 seconds. So therefore, it is unlimited scalable, the serverless operational model. And you don't have to worry about it. You don't need people to maintain it. The architecture is also event-driven. Now, this is also difficult to understand, but to make it, because this is a lot of concepts for a beginner, event-driven is basically that user custom events. You say order has been placed, and basically the order event is fired, and then you take care of it on the client and maybe on the server. Of course, also on the server. Data is stored in modern globally distributed databases, and they are custom databases. For example, if you don't need querying that much, you can use MongoDB. If it's a financial application where you can use SQL servers, but they have to be cloud-based and globally distributed so that they can take the load. Of course, there's a new database, FaunaDB, that has just been announced in the last 2-3 years, which has a lot of different application models. We will discuss it later. Now, the next part is very important. Services are connected with GraphQL query and real-time subscription APIs, which is both, as you know, everybody knows GraphQL has 3 parts: queries, mutations, and subscriptions. Subscriptions is for real-time databases. So the connection between client, it may be a mobile app or a web app, and the server is GraphQL. And then that GraphQL server talks to a lot of different, it is basically a facade pattern, design pattern. It's also an API gateway. Facade pattern, we will discuss everything in detail later on, because otherwise we'll be stuck in this single para for 2 hours. Then it says agile developers processes that allow organization to innovate faster and reduce risk, time to market, and total cost of ownership. We are using basically agile development processes to basically create innovation. Now there are 2 types of application. We are going to discuss it. Modern web apps include single page apps, which most of our students have learned by using React apps, CRA, and static site generators like Gatsby and etc. Both use React components, but there are 2 different types of applications: single page apps and static site generators. These applications do content management typically using Headless CMS. Contentful is an example of a Headless CMS. We are going to sum it all up later on. And modern applications also extensively use the power of automation with continuously integration and continuous delivery. Now, this is very important. What I want to do is, as a developer, is that I want to develop locally on my machine. Zeeshan, I want to develop locally on my machine. I want the server, the client, everything on my machine so that I can see what is happening. Once I develop it, I push it on the Git. And the idea is that it is a single source of truth. As soon as you push it on the Git, it basically deploys to different servers. And the users can use it or whatever. Maybe not users directly, but it depends on the application and a lot of different things. So therefore, I have given modern applications. Now you have to understand something. The application development languages and the frameworks like React are open source, like Gatsby are open source. They are not provided by the cloud providers, except for one of exceptions are there, but generally they're not provided by the cloud providers. So therefore, we are going to discuss 3 client-side frameworks. One is Create React. All 3 are based on React. Create React app. Number 2, Gatsby. And number 3, Next.js. All 3 are based on React component technology. And on the server side, we are going to see, because there's a lot of stuff, I'm going to, if I start talking all of them at the same time, it's too much data for a new person. What I'm going to do is divide it into. The first thing is, the most prolific and the most market share is held by AWS. We are lucky. Daniyal is a certified AWS developer. So we are going to ask him some questions, but later on. First, the people who do not have that much AWS experience compared to Daniyal. Daniyal is a certified developer. Adil.
Yep.
How do AWS perceive? I've given you the general perception about modern applications. What kind of, now on AWS, it does not give the frameworks, but it gives the deployment technologies. What are the different concepts AWS proposes, and what are the technology deployment technologies they are providing?
Sure. Can I open some of these links and we can go through them as well?
Anything here, you don't have to ask me.
Okay. So this is one of the pages from Amazon AWS called Modern Apps. And if you come inside of here, we can see the different, what they say are the different elements of a modern application. So, and then it has a 5 high-level objectives here. So the application architecture, inside of which you have the microservices, right? So you have the Amazon API gateway, the AWS Lambda functions, and then the Dynamo database. So these are some of the tools in terms of the application architecture. That this is the way that we'd be building the services, and then the Lambda functions would be the serverless infrastructure, or just the serverless. Okay, and then in terms of the delivery, we have, here we go, if I can zoom it in. So AWS also gives us its own Amazon-owned CI/CD. So we have the AWS code commit, the pipeline, and then the code build. This is the CI/CD tool from Amazon itself. So we could use this if we're following the Amazon architecture. If we're following the entire set of tools, and then in terms of data strategy, if we look here, depending on what the application is, whenever you get a request, you can route it to either the Amazon DynamoDB or the Amazon Aurora DB, which is more a microtransaction, or DynamoDB is more on the database that's more scalable. So we have this for how we store the data. And then in terms of the operations, for the serverless operations, you would have the AWS Lambda functions. And then for governance, they have some AWS WAF filtering rules you would have for more security kind of things. So these are the different tools, the entire tool chain that you would have if developing a complete modern application with AWS.
Thank you so much, Adil. What we are going to do is, before we move forward with Zeeshan and Daniyal on this, I want to cover basically, because it is irrespective of the deployment architecture. No matter what application you are developing for Amazon, Azure, Google Cloud, Netlify, or Vericel, there are these 5 providers, main providers of modern application deployment, which you are using. We will use the concepts on all 5 of them. What is those concepts? I'm going to move to the second topic, and we are going to come back because there's a shortage of time. So therefore, I'm going to come back. Otherwise, it will become too much. There are 3 concepts. One is server-side rendering. The other is, could you, Adil? Yes. SSG is server-side generation. SSR is server-side rendering. And CSR is client-side rendering. There are 3 concepts. Now, there are 2 technologies that implement them, which is Gatsby and Next.js and Create React App. These 3 things: Create React App, Gatsby, and Next.js. All 3 are based on React. Zeeshan, could you explain a bit what are these 3 things?
Basically, the start of this thing, as you have discussed previously, that after the Ajax, we have started implementing the rich application on the client side. So client have become thick, and we started working on the application which do a lot of things on the client side. So because of that, there were many client side libraries or frameworks introduced, React and Angular included. What React and Angular do is basically you develop a single page application. What happened is whenever you build an application, you receive complete HTML on the client side in the first request. And whatever you try to do, you move on a page, you click on a component, you see a pop-up, anything you see, all these things are working or business logic of displaying UI on the client side. So when you say the client side rendering or client side display, the React or the Angular, they work as a client side rendering. What it is, as I've explained, that if whatever component you click, you want to move on another page, you want to see any pop-up, all these things are done on the client side. And you do the request to receive a new HTML does not go to the server. There is no next request for the fetching the UI on the client. All the component, all the content, all the HTML you receive whenever you first time call to the server, and you receive a complete HTML at the client side, and everything runs in the client side. There is detail how these things work, but when you say client side rendering, so complete HTML is received in a single request.
Zeeshan, when you are mentioning HTML, you mean JavaScript and
yeah,
HTML.
It's basically a JavaScript, yes, because browser display JavaScript. So you receive a complete JavaScript and the first go, and it renders on the client side in the browser. And whenever you switch the pages, as we have learned React and we have seen the routing of page shifting, all these things are done on the client side inside the browser. There is no server request even for the switching for the pages. That's a client side rendering.
But the data comes from the server.
Because let's say I need to sign up a user, login user, I need to fetch detail of my courses or my emails. So that definitely we request to the server and data comes from the server. So it's just a data call API. You call to the server and you receive a data and you display that on the client side.
Okay. Now, and this is called a single page web app, SPA.
Single page web application.
And this is created by Create React App technology.
Yes, the basic provided by the Facebook.
Zeeshan, what is SSR? If CSR is client-side rendering, SSR is server-side rendering, what is the difference between CSR and SSR?
SSR rendering in your application, every page you receive from the server, it's like you are if you can see it as you are back in 1990s or in 2000, where whenever you want to request a page, you request a page, you go to the link, it requests to the server, and new page comes to the client. So in server side rendering, your React converts your page into HTML and JavaScript on the server, and then you receive that page on the client side. So if your application have 4 pages, in client side rendering, all those 4 pages will resides on the client, and you just switching the pages. But in server side rendering, you will receive each page whenever you request for a particular page. That particular page will convert from React to the pure in JavaScript, and you will receive that page.
That conversion to HTML will be done in runtime. So therefore,
Yes.
there will be a lot of load on the server.
Yeah, everything will be done. So that's why I was saying that we are in server side rendering. It's like we are back to 1990s or 80s. We are 20 years back, because for every new page request we will receiving a new page from the server. But why it is needed is because of SEO. Each time we develop a React application with client-side rendering, it just switches the pages. It just a particular div and content just you add a content in particular div and you remove a content. If you switch a page, the div stays, the content within the div changes. So it's difficult to manage search engine optimization with the single page application. So that's why we need to help servers to search engines. We need a server side rendering, or we need a solution which helps search engine optimization. And for that, Next.js provided us a server side rendering, where whenever you request to for a page, it request goes to the server, it converts the page, and then you receive page on the client side. So for each page, you have all the metadata in that particular page, and you will receive that page. So it's search engine friendly, and search engine optimization can be much better in server side rendering.
Okay, so let me summarize. In client-side rendering, we send the JavaScript to the client. The JavaScripts request data from the server, which requests data from the database. That database gets to the client. It builds a complete page and shows to the client. Of course, there's a bit of lag, because for a few seconds, a blank page will appear in single client-side rendering. And in client-side rendering, there will be a little lag, but the performance overall and the user experience will be just like an application.
Yes.
On server-side rendering, the problem is it takes a lot of load on the server. The performance is slow, but it is very good for SEO. On
Yes.
client-side rendering, the problem is that Google will have a difficulty in searching and basically indexing the pages. It has improved a lot in 2020. Google bots have improved a lot, but still there's not as perfect as you are going. Now I'm going to put Daniyal on the spot. He is my buddy, so therefore I love. Zeeshan was saying server-side rendering is 20 years old. You're going back 20 years. Now we are going to static site generation. generators. But
It's even older.
if you remove the word generators and just go to the static site, it is 30 years old. It was the beginning of the web. We are going back to the beginning of the web, the static site generation. Daniyal, what the hell is static site generators?
Sir, static site generator is basically when we compile the app. On that time, let's suppose I start with React, client-side application, client-side rendering, and then I came on SSG, server-side or static-side generator. Basically, when we compile the code in React, how it works? The code, the source code, it comes up on browser. Should I share my screen?
Yes, of
So
course.
Sure.
yes. So here you guys can see, if I go here and inspect how the application is, can you see my screen? Okay.
Yes,
Yes.
yes.
Yeah.
Okay. Here I show you here in inspect element the source. Here is we have a complete source code of the application. Let's suppose, just assume this is our React application, and I just run the npm start or yarn start. So the application is compiled. The build, the source code comes it here. And when I just, as Sir Zeeshan explained about the routing, when I click on another page, so this source code is exactly we have loaded earlier, the whole source code of the application. But I'm just continuing Sir Zeeshan point, as Sir Zeeshan said about SQ as well. So what is going here? This is very important concept. The code is always here on first load of the application. But when I am going on another route, so it will not update the here source code. It will update only DOM from here. So what is I'm trying to say? Let me show you.
Daniel, you're talking about client-side rendering. You just gave an example of.
Yes, sir. Client-side rendering. I'm talking about the client-side rendering right now. So here is, let's suppose this is our client-side rendering. I'm going to show you here. Yes. This is, I just created a application of from on Node.js, on Next.js, server-side rendering. Here I'm going on client fetching. So what I'm trying to say, I just show you. Now you guys can see here,
Yes.
this is basically something like a React application. The HTML is here. We have the HTML, but not the data, the fetch data, which I call the fetch API from here. This one. What I'm trying to say, I explain it again because this is very important concept of client-side and client-side rendering or server-side rendering. This is basically a fetch request. Here I'm in use effect calling this. When I load this page, I'm talking about the client-side rendering. Here you guys can see I'm going on view page source code. Click it here. Now you guys can see here is we have HTML and CSS. Why? Because when it load, it comes only with the HTML tags or HTML JavaScript which we have provided statically, like this div tag. But when I'm going on routing, using routing, so this is not updating this HTML. This is the major difference on server side rendering or client side. Now I am going on, I'm clicking on to dos. This is my server side rendering. And how it works with SEO, this is I'm trying to saying. Now you can see here, this is coming with all the text which we are calling here. Now I'm trying to I'm explaining it again. Same thing, this one and this one, but this one is with client side and this one is with server side. Now I explain it again. as we start the React application, npm start in the terminal, it compiles the code. When we hit localhost 3000 here, first what it will do, it will come here, just click, just inspect element. It loads all the source code of the application here. So what it means? It means, let's suppose in the to do component we don't have we and in another component, let's suppose we have a home component. On that component we have a fetch request. So what it will load here first time, it will just load static data, HTML, CSS, JavaScript. And when I click on the home page, the fetch request, the API request, it will call, but it will not update it, the source code here. It means not as well here in, let me show you here in client side fetching. So the basic point, I want to continue the Zeeshan point. Here is server side SEO, search engine optimization, as Zeeshan said. For the server side rendering, we have SEO is very good. So the main reason is this: in server side rendering, we have the page render with all the data, and on this data, on this text, we do SEO, search engine optimization. That is very difficult SEO on client side rendering. Do you get my point, sir?
Yes, yes.
This is basically, so how we can do search engine optimization on client side? We can do statically. Let's suppose the keyword I will enter manually here, and manually I will put the data here, but in dynamic way we cannot. This is very difficult challenge. This is the main reason server side rendering. Server side rendering comes the page comes up with the page with all the data. Let's suppose like this. This is the fetch request API, but you can see here in server in client side there is no any data. We have to put static data in the HTML. According to that static data, we can do SEO, but in dynamic way we cannot. So this is the SEO perspective of CSR, client side rendering or server side rendering. Now,
Anil, let me just, before you move forward, let me summarize what you said.
Yes, sir.
What you said is, you gave an example of a page which was doing client-side rendering. In that page, you could only see HTML, CSS, or JavaScript. There was no data.
No.
Because data is going to come later.
Yes.
So therefore, how is the search engine Google bot going to find the data? Of course not. So therefore, SEO will be very bad.
Exactly.
On the server side rendering, the data is taken on the server, whole page is made and sent to the client. When it reaches the client, the HTML is there, the CSS is there, the JavaScript is there, and even the data is there. So therefore, Google can read the data and index it.
Exactly. Perfect.
Now, Daniel, we want to go even backwards and forwards at the same time. That is server-side generation or static. Let's make it static site generators.
The Gatsby is sorry.
What is static site generation?
Static site generation is basically, as we discussed about CSR and this. Static site generation is as client side rendering is on runtime. Server side rendering is on runtime. Static site generation is on compilation time. When we run the application, when we build the application on compilation time, it generates the pages, not on runtime. Let's suppose I have a Gatsby application, or let's suppose I have a React application. I'm going and write npm build, and then serve that build. So that I have multiple pages. Let's suppose I have 5 pages. Whenever I will go on that route, on that runtime, it will build. But on the static site generator, when we develop it, when we build it, on compilation time, it will generate all 5 pages, not on runtime. Let's suppose I have a HTML page, I have HTML, I have JavaScript, or I have database, or a database is contentful CMS. So what will, whenever I will change in database, whenever I will change in CMS contentful, as I think everyone knows about contentful, or if the student doesn't know about contentful, don't worry about that. This is basically right now you just understand this is a database. Let's suppose we have a database. When we change in database, it will not reflect on the UI in SSG, in static site generator. So what we need to do, we need to build it again, or we need to develop it again, the command. We need to run the command again. Why? Because the static site generator render the pages, generate the pages earlier. Let's suppose on compilation time, it render pages on compilation time. And this is the benefit. The static site generator application is most faster than other client side or server side rendering. The
Thank you
reason
so much.
it is generated on compilation time.
Zeeshan, could you
Yes.
explain static site generators a little bit?
First, let me explain what we are, as Daniyal was explaining, the build. For that, students need to go in our initial classes, first or second class. We were deploying our application on the search. So we were running two commands, npm run build. What it does is basically it converts your React application, parse everything, and generate single JS file, and it builds a single or one or two JS file and gives you those JS files, and then you deploy those files to the server, and then your uh, you request to the particular server and you receive data from that server. So we are doing build way we were doing previously. So it's not different anything, but talking about the building, it means that we are creating a production content so that final JS that will be delivered to the client will be available, and whenever and deployed to the server, and whenever we request to the server, we receive that content. In client side generation, it only generates the HTML, CSS, and or you say only generate JavaScript, which needs for the UI presentation. So it only generates the UI. And when you receive the UI, you send the request to the server to fetch the data, and data comes later on. So when you I'm talking about the client side rendering. So when you request the server for the website or application, you receive complete JS for the UI, and you fetch data later. In server side rendering, the process is same. You build the application, but the only difference is in server side rendering, it gives you multiple pages because you have created multiple pages, and each time you request for a particular page, it returns you on the server, as Daniyal showed you. It all the data loading, data fetching done on the server, and you receive final HTML or final JS on the client for a particular page. When you call for the second page, it will go to the server. Again, it will generate a page. It will load the data and receive. If you call the previous page again, it will the process will be same again. So request will go to the server. It will load the data, and you receive final JS on the client. That's how server side rendering. In static site generator, what it does is when you build the client, when you build your application, it's not that client is requesting. You are building. You want to deploy your application on the production server. So at the build time, what application does is it fetch all the data and generate the pages, the final result. What the final result was being done in the server side rendering for every request. So whenever I request for a page, the page converts, it parts everything, it fetch data, and you receive the page. In static site generator, all this process is done at the build time. So before deploying to the production server, you have all the pages and you have all the content in those pages. So your pages are ready, and whenever you request to the server, it returns each page separately, but the page has all the data. So the parsing and fetching data on every request will not be done because it's already being done in the build time, and you will receive directly HTML to the or JS
It is being done on build time on the server.
On the server, definitely. Basically, build time, what you say, you cannot say build time is on the server. It means that it's done by the CI/CD and it deployed on the server.
Yes. So therefore, let me summarize what you have mentioned. What you are saying is basically that server-side generation is a method in which it has nothing to do with the user. Before deploying the website or the web app, what you do is take the data out from the database, populate the React components, build a complete HTML page, and if the complete web page and make it convert into HTML, and then deploy it to the client. Therefore, when the client queries the data or goes to that page, basically everything is already done once in batch processing, and the client is basically just taking the data. The good thing is on this server-side generators, you can deploy on CDN. Zeeshan, what is a CDN? Content Delivery Network.
Basically, CDN, as you can imagine it as, there are many servers in all the regions and they have lot of space, or you forget about the space. There are many servers in all the regions. Whenever you want to you want your application or your image or your JS, anything, you want to be accessible globally and fast. Because if you are deploying, as for example, if I'm deploying with the Hariku, or I'm deploying any platform to deploy my application, it will deploy on a particular region. For example, in US or East zone or in West zone, there are different zones. So you deploy on a particular region, so your application will be deployed on a server in US. So if you are requesting from the Pakistan, or if you're requesting from the any Asian country, so it will be a bandwidth problem, because it will require data to fetch from that server which is in different region. What CDN does is, CDN has databases in all the region, and whenever you deploy your JS, your HTML, or your image on CDN, what it does is it distribute that image, for example, or JS on all the servers. So if I'm accessing from the Asia, I'm accessing from the Pakistan, so it will go to the nearest server. If I'm accessing from the Europe, or for let's say in a Germany, so it will go to the it will access to the nearest CDN server, and based on that, the response time will reduce, because the data will be coming from the nearest server instead of going to a particular region server.
So therefore, when I say that static site generated content is easily accessible to on CDN, what does it mean?
Easily accessible to the server is because when you generate, the problem with React or the client side rendering is, whenever you receive the data, it render or it generates UI on the client side. In server side generator, at every request it done on the server side. So whenever you request to the server, it page parses and fetches the data and return. That's a server side rendering. In servers, in static site generation, the complete page is already being done, so it's a static HTML. So in that way, you don't need a server, you just need any place where you can place your HTML file. So CDN is very good in that, because you can place your HTML files on CDN, and whenever you request the file, you receive an HTML directly. So you don't need a server whenever you are talking about the static site generation.
Okay, thank you so much. Now, there are three things. Let me summarize. One is client-side rendering, the other is server-side rendering, and the third one is server-side generation.
Static site generation.
Sorry, static site generation. The third thing is now, we encouraged our students not to use server-side rendering.
Rendering.
Zeeshan, why we are not proposing that?
Because of many reasons, but the most important is because every time you request to the server, it passes on the server, it fetches data on the server, the complete load is on the server, and it will become the older way of building an application where on every request, and there will be a latency. In client side rendering latency, there will be a latency, but only when you load first. When you request to the server, you will receive complete JavaScript and HTML on the client side. It will wait or it will take few seconds. But in server side rendering, on every request you have to wait, because until server returns you the page, you will have a blank page. So past, when in 90s or 2000s, when we were requesting to the server, your all application will be a blank, your browser is a white page, and it send the data and it loads slowly. So it increase the load on the server, and create generation of pages and fetching data all done on the server on each request. So whenever you request, it converts the page and sends you. So it will be load for the server, it will be heavy for the bandwidth, and it will be definitely difficult for clients, because it will always, you need to wait for seeing a first paint on screen.
Okay. To summarize, we are suggesting to our students and to our developers, if you are developing an app, a single page web app, use create React app, sorry. If you want static site generation, use Gatsby. The good thing about Gatsby is that you can do client-side rendering as well as static site generation on with Gatsby. Next, you can do all three, but it's not as mature as Gatsby. Gatsby has a lot of, and the main advantage of React Next.js was server-side rendering, which we are not using. So therefore, we suggest to all our students to use Gatsby for developing even single-page web apps, also developing static site sites. Now we go forward. Adil, what is Jamstack?
Right. So Jamstack builds on this static site generation concept. It stands for three things. So the JAM is it's not Gem, it's Jam. So JavaScript, APIs, and the pre-rendered markup. So the objective is that you'll have the static site generator that would have the pre-rendered markup at the build time, and it would be hosted on this CDN throughout the world. And instead of having this client-side generation or client-side rendering or server-side rendering, you would use the content delivery network to deploy to give users access to the pre-rendered pages through the content delivery network. So that's in short Jamstack.
Zeeshan, would you like to add anything?
Basically, it built based on existing things. There is no Jamstack is nothing new. There is nothing new in Jamstack. It's just combine all these things. We are talking about static site generation, which is a separate concept and provided by the Gatsby and Next.js. So we generate a static page. And it says that if you need a logic, if you need a business logic, you talk to the API. And the main concept of Jamstack is you talk to the API which are pre-built. For authentication, you use Oath. For a payment module, you use Stripe. For business logic, you use. And for databases, the Jamstack directly, or if you are in the Jamstack way, go for the FaunaDB, because FaunaDB also works with the API. So you have a static pages, to talk to the servers, if you need anything authentication, do authentication with oath, so you will not have a server. If you need to talk to the database, go for the FaunaDB, you will directly call the API, and it's done. So it's a concept, a combination of existing concept, the Jamstack, the server side APIs and markup.
Daniel, what
Yes.
is the in Jamstack the main technology being used by most people is Gatsby. And what is this Gatsby thing? And how is it different from Create React app?
Basically, a create React app, as we have already discussed, the client side rendering, that is the runtime generation. The pages are built on runtime. Same thing if you go on Gatsby, SSG, static site generation. So it build the pages on compilation time. Also, we can do on CSR, client side rendering on Gatsby, but the major thing is SSG in Gatsby. So that is why we are using Gatsby for this perspective, and also the Jamstack technology.
Daniel, what is Contentful? How does
Yes,
it connect to Gatsby?
Contentful is basically a content management system where we put our data, where we manage our data. As the main problem is the database. If we have any application, any website, the content management is always a problem. If I just write the, if I have a requirement for one application, that is e-commerce website. So once I build the application, as well as I need to build the admin panel for the uh, uh, user which they are using, which they are providing the services. So as a shopkeeper, I will create a admin panel as well, because on the daily basis they need to put the products. So contentful is basically a content management system which they are giving us the complete content management facilities, where we can put the data and we can get using Gatsby. That is basically a database. You can say.
Therefore, content basically CMS is called Content Management System. Contentful is a headless CMS.
Yes, sir.
Now, why do you use a headless CMS with Gatsby? Just to summarize the thing, what you do is basically at build time, not at runtime. At build time, instead of hard coding all the text, all the data in the website, because later on, if the customer wants to change it, he will ask you and you will have to do it, because he cannot basically go and fiddle with the code. So therefore, the best thing is that
Yep.
he designs the content in
Yes.
a CMS, and from the CMS at build time we extract the data and build the HTML pages.
100%.
Before that, there was a concept word of basically a CMS, which was WordPress. Zeeshan, what is the difference between WordPress and this headless CMS approach?
Basically, when we started learning client-side application, even if it's an Angular or it's a React, whenever a request comes to me or a client wants me to build a website for the client, let's say a client has a product and client wants to build a website, so clients can showcase that. There will be about page, there will be contact us page. Always, there was time that every time WordPress developers steal my business for website applications, for websites. Why? Because WordPress has complete CMS in which you add the pages, you add the content, and it generates the website. And whenever you want to change anything into the website, user has the or my customer has the access to the WordPress UI. If customer can change the UI and customer can add new pages, and all can be done. So always WordPress developers was stealing my business for the if I want to develop a website. So I was not able to do it, because in React or in Angular I need to develop an application, a website, and then I have to develop another application, like Daniyal says, an admin panel which helps my customer to add pages, to update content, so I need to do a lot more work. But WordPress has that capability. The problem was WordPress is an opinionated, because WordPress has everything. WordPress provides direct. It's a complete what you say. It's a complete application. It has a database. It has a client side and server. Everything at a single place. So you do not have a choice if you want to change the client side language. If you do not have a choice if you want to change the database. If you do not have a choice if you want to change the server generation or server, because it's a single WordPress, and whatever it provides you, you have to build application in our website in WordPress. Now, uh, for React or Angular, we do not have such systems. What the headless CMS is basically, the problem with the WordPress is I cannot select my client, I cannot select my database, I cannot select my server. I have to use the whatever provided by the WordPress. In headless CMS, what the quality of headless CMS is, the contentful, which we just discussed about, it just provide the area to database. It just provide the location to data, your content. It's just a content. It does not provide you how you display that UI. It just provide you to management of a content. So you want to add a page, you want to display a content, you want to edit a content, you use a contentful, and you just update the data. There is no UI. You just go to the contentful website and you add your content, anything you want to add. You want to create a page or everything, that all is data. There is no UI. And then you can create UI in any application you want, any client you want. So I can develop a React application and connect that React application to the contentful. I can develop a Angular application and connect that Angular application to the contentful. So the benefit is I will develop a website in React, my preferred language, or Angular, and I will use a contentful and load all my content over there. The benefit is I can give access to my customer to the contentful, and whenever customer change the content, the UI will be updated. I have skipped the site generation process just for the simplicity. So whenever customer add new data or add new page, it will update it, and the user will see the new page or updated changes. So headless CMS, the basic you need to understand is headless CMS means it's only a content. There is no UI. You can select whatever UI you want, and we can use Gatsby for that. So it will be much. We'll discuss it later, but for the simplicity, it's a server or content server with only data.
Okay. Now, just to summarize, Contentful provides you a GraphQL API. With Gatsby, what we do is at build time, before what we do is maybe a content writer, we ask the content writer of a company to build all the content for the what is the web, that English, whatever the pictures, maybe the videos, all the content is provided and uploaded on Contentful. We as developers using Gatsby at build time basically extract that data, combine it with our React thing in Gatsby, and develop static pages so that whenever they change the data or the content, we have an automatic pipeline which is called a CI/CD pipeline. We update the HTML page. So therefore, the WordPress on what do you call founder is getting very jumpy these days. You must have there are a couple of articles attributed to him and his comments. He is saying he is getting very angry at Jamstack, and he is saying it is regression. We are going back, which we are going back, but we are going, which he is not wrong in this, but we are going back in an intelligent way. The problem with WordPress was because all the queries were done at runtime, the websites were very slow, and most of the big companies were not using WordPress. Only small companies which do not have and you cannot deploy WordPress in a content delivery network. Therefore, there were a lot of problems with WordPress, and right now those people are getting quite jumpy, WordPress people, because Jamstack is thinking about eating their lunch. Now, what we are going to do is now move forward. Daniyal, Netlify.
Yes, sir. Netlify.
Just to make a brief comment before you get started, I am surprised. Netlify is a small compared company to AWS and Google or Microsoft, but it is giving a run for their money. And Netlify, basically, AWS has created a competitor. Azure is, which is called AWS Amplify. And Netlify is basically, they have not invented Gatsby, or they are basically a deployment company, a cloud company, just like Microsoft or just like AWS. So therefore, there are 4 competitors now. Actually, there are 5 competitors, as I mentioned. Netlify, 50% of the websites that are being deployed on Jamstack or Gatsby or Next are being deployed to, mainly Gatsby, are being deployed to Netlify. They have 50% market share at this stage. So therefore, all the companies are getting jumpy, cloud companies, and so therefore the competitors are Netlify, number 2, AWS Amplify, number 3, Google Firebase, number 4, Azure Static Pages, number 5, Vercel. Now, what is this Netlify thing?
Netlify is basically a platform where we can deploy the website. This is basically a deployment company, as you have already mentioned, but with the combination of Gatsby and official documentation, Gatsby prefer and recommend Netlify. So this stack, a complete stack for the developer. As a developer point of view, I don't need to worry about where I will add the data, the contentful we have, where I will build the business logic Gatsby we have, and then finally where we deploy the application. The application is built. I have built the application in our local machine, but where I will deploy with the Netlify, the stack is very good and is very simple. Using the graphical user interface, we can deploy our website on Netlify, and more than that, we have, let's suppose, as Sir Zeeshan said about contentful, whenever we change it, we need to build it again, and they will again generate the page. So with Netlify is also providing us the facility with contentful, with Gatsby as well, with contentful as well. Whenever we will change in database, we can generate the webhook on Netlify. Using that webhook, we just connect that webhook on contentful. We don't need to do anything. There is complete GUI, graphical user interface. I will just go. Earlier, we need to make the YML file for CI/CD and a lot of things. Now everything is very simple. Netlify is simple. We can deploy our website. You also implement. We can also integrate the repository, GitHub repository, Bitbucket repository with Netlify. Whenever the code will push, the CI/CD automatically run and it will deploy the application. Whenever I will go and change on contentful in database, it will again using CI/CD, it will build the process and deploy the application again. Same thing, it is in background, it is just providing a virtual machine. In virtual machine, they are cloning the code and building and deploying everything. So same, Netlify is basically for the deployment perspective.
Very nice. Now we are moving to serverless. Daniyal has a certification in serverless. We are not in this module. We are only going to develop Lambda functions. Later on, in an advanced module, we are going to cover serverless with a lot of different things like Azure, AWS, Event Bridge, AWS step functions, and a lot of Cognito and lot of AWS other things, and also Google.
Services.
And there are a lot of serverless services now coming up. But just where it gets started, serverless got started by Lambda functions. Daniyal, can you explain Lambda functions a little bit?
Yes, sir. Exactly. As we need any server side language, if we code in the server side language where we will deploy it, definitely we need a server to deploy the server code. So Lambda function is basically same as Sir Zeeshan earlier said, cloud function. So Lambda function in AWS is providing a Lambda function where we can do any code, Node.js, Python, Java, so many server-side code we can do in Lambda function, and we don't need to worry about the deployment. They will just give us a endpoint, and we can hit it, and no worry about the scalability as well in Lambda.
So, okay. So, therefore, what we are going to do is that Lambda functions are basically simple functions. We just give a function. Everybody knows what a function is.
Yes.
You just give a function to a server and say, please run it.
Exactly.
Now, it is the responsibility of that service provider to basically scale it, make sure that it doesn't break down. If it breaks down, restart it, and rest of the stuff. We do not need anybody to monitor it.
Exactly. We don't need to worry about it.
Therefore, serverless means we don't have to worry about it. Serverless doesn't mean that we don't need a server. The server is there, but we don't worry about it.
Exactly.
Now, what we are going to do is, the good thing is Netlify, normally if you want to use AWS, you need a credit card. In order to use Netlify, you don't need a credit card. For our students, it is very good because in Netlify, you can deploy AWS functions exactly as is. So therefore, you won't need AWS account. We'll need an AWS account later on when we go into serverless in depth. But right now, you don't need we are going to do development in this module, basically on Netlify, and they are using AWS Lambda functions. That's a good news.
Yes.
Now, the next thing is FaunaDB. FaunaDB, when we talk about FaunaDB, think about it. There are three types of databases right now, which I have used. One is the relational database, the other is document databases, and third one is graph database. The good thing about FaunaDB is you can do all three types of models in FaunaDB. The other good thing about it is that you basically it's unlimited scalable because it's totally distributed. It is built on top of AWS as well as Google Cloud, and basically it implements Kelvin protocol, which is a distributed protocol. It is ACID. The thing is, if you make a transaction, either it will fail completely or everything will be committed. MongoDB till recently did not have it, and for distributed, if the databases are in different, so MongoDB did not have it. With MongoDB, we will also use MongoDB in our courses, but I like FaunaDB better than MongoDB because of two reasons. Because of the three models. The second thing is, in MongoDB, the model is very simple. It's a document database. And in order to have foreign keys and the rest of the stuff, it becomes very difficult to model things. There you have to do a lot of copying of data. So therefore, it is very difficult to manage complex applications, complex data bases. And I was always unsure whether, because it was not ACID in the distributed sense. Right now, they are improving on this account. But the thing is, MongoDB, I was always worried about financial applications not to use it. Because in a transaction, if it fails, some of it might be committed and some of it might not be committed. Then moving forward, GraphQL. Zeeshan, before we get started, you have to understand something. You have to think. We are in a microservices world. You know, the other thing the WordPress guys has against Jamstack, he's saying you have 50 different APIs. And he's right. In your application, if you are using 50 different APIs from 50 different sources, it will be a noodle. It will be a mess. It will be spaghetti code. And he's right in this. So therefore, but what he most probably did not, because he is basically a competitor, therefore he is bad mouthing Jamstack. But the point is, you have to understand, we are calling databases at 2 times in Gatsby. One is build time, the other one is runtime. You can call Gatsby, GraphQL, or any other databases or any other APIs 2 times, either at build time or at runtime. Let's say build time. You basically call GraphQL and can get all the GraphQL data from Contentful, because front end of Contentful is GraphQL. On the client side rendering, you are calling 10 different APIs. You are calling Stripe, you are calling Google Maps. What you can do is build a single federated GraphQL API, combining all these APIs. And combining all these APIs in a single federation. Apollo has this federation thing, and basically combining. But another company, so therefore, one is Apollo, which develops both. We are going to use the client side of Apollo, and for the server side, we are going to use 2 technologies. One is maybe the server side serverless of Apollo, and the other one is a new company that has come up very recently, Hasura. Hasura has been very good in developing backends which connect to multitude of different APIs. It can be a database, it can be other GraphQL APIs, it can be REST APIs, and basically, and this thing is also has another very strong competitor. That is AWS AppSync.
Yes, sir.
AWS Sync is providing the same functionality. So therefore, we have basically 3 very strong competitors. One is AWS AppSync, the other one is Hasura, and the other one is Apollo Server. These 3 things, all of them do the same thing. Build robust GraphQL APIs. Yes, Zeeshan.
Basically, there are minor difference in Apollo. With Apollo, what you can do is you need to develop your own server, and you create a Apollo server, so your client can talk to the Apollo server, so that GraphQL can work directly. With AppSync, the benefit of AppSync is there is a benefit and there is definitely pros and cons, because you are on AWS. The benefit of AppSync is it provides you a server, so you don't need to develop your own server. You can directly contact to the AWS AppSync. Your client will directly talk to the AppSync, and AppSync talk to the database, which is DynamoDB or AuroraDB in AWS. So you don't need to develop a server. For Apollo, we need to develop a server. And Hasura, it works for the Postgres SQL. So that's the difference in these 3.
Yes, you are 100% right. So the point is, we are going to go very deeply into GraphQL, because this is the future backbone of all client and server communication. And all the major companies, as you can see, as I have noted in the articles which I mentioned, a huge investment in these companies are going on. Now, we have, at this stage, I want to mention Firebase. 5-6 years back, I started using Firebase. Initially, I loved it. There are 2 technologies which came very close to destroying my career. One was Silverlight, which I loved, I supported, and at the last moment, Microsoft pulled it off, because HTML had come around and they had changed strategy. The second was Firebase. Firebase real-time databases are unique. When I started off, I loved it. But the problem with that is that when it is very simple, when the application is very small, you will love Firebase. As soon as your application size increases, Firebase will be a pain in your bee. It will create so much problems for you because there's no type checking. Now, what I love about GraphQL is that it provides three things. Number one, it provides query, which of course we will use. It provides mutation, which we use. But it's so. The most thing I like is the subscriptions. It provides a typed interface for real-time data. And it is a universal standard in the sense that it is an open system. The specifications are open. Firebase was a proprietary system. Therefore, I'll suggest to my students that don't use Firebase databases. What we have to do is we have to stick with GraphQL because it is standard, and for larger applications, it is type checking. GraphQL has the types, so therefore it helps you a lot. But there's one Firebase thing, two things which are good. Actually, three things. One is Firebase Authentication. It is the only authentication system which is totally free for unlimited use. So for authentication, you are going to use Firebase. It is also very good and equally good as Netlify for edge deployments, for static site deployments. And the third thing is, which Daniyal has taught, was the
AWS Cognito is also, sir, very good for authentication.
What are you saying?
AWS Cognito is very good for authentication as well.
Cognito is very good, but it has a cost involved. Firebase is totally free for unlimited use.
So far, I have used from 2 years. I did not pay a single penny for AWS Cognito.
No, we are going to, not in this module, but in the next modules when we are going to go to complete serverless thing, we are going to move towards AWS and Cognito. And the only outside serverless thing we are going to use is serverless containers, which is Google Cloud Run. So we are going to combine Google Cloud Run with AWS and not use Fargate because Google Cloud Run is better than Fargate, except for the rest of the stuff. AWS, at this moment in time, AWS serverless computing is far ahead of any of its competitors. So we are going to use Cognito also. So therefore, the point is, but for at this stage, because we are assuming that most of our students do not have access to AWS at this stage, we are going to use Firebase authentication because the concepts are the same. So therefore, what we have learned so far is, and then at the end of this theory, there are three other concepts. One is WebAssembly. The other one is Project Fugu, and then the CSS Houdini. The thing is, we have to understand, I mentioned these three things here. As we are moving forward, the days of native web application development are getting behind us. There are so many new technologies that are coming up on the website that it will be very difficult for native applications to compete with them in the long run. They will not go off completely because of specialized applications which will need them. For most enterprise applications, corporate applications, web platform, and if somebody wants to go with the installed applications, React native will be good enough apps. And the point is that the web platform is moving fast very quickly. And with WebAssembly and CSS Houdini and Project Fugu, which you can read because the references are there. But let me now summarize the whole thing. Number one, what we have learned is static site generations. We'll be using two kinds of apps. One is static site generation. The other one is client side rendering. We will be using these two concepts. Either through Create, once your customer wants you to deploy an application, you will have to see whether he requires a SEO. Most of the applications require SEO at this stage. So therefore, you will use Gatsby or Create React app. There's the front end. And of course, it will be using React components. At this stage, we will use Netlify to deploy it. For the API part, if we have to develop our own API, we are going to use serverless technology. In the long run, serverless is going to take over everything, replace everything. Nobody will be able to compete with serverless because the concept is so strong, very difficult to compete. For private clouds and hybrid clouds, Kubernetes and containers will be a major competitor, but the applications will be either using serverless or using Kubernetes. As we go forward, then we are talking about talking to the API layer. The API layer is GraphQL, and we will be learning this in this module extensively. We will develop, Zeeshan will develop clients, we will develop servers, and we will do a lot of things. And therefore, there are 2-3 major things. Number one, Gatsby. Number 2, Netlify. Number 3, serverless functions. Number 4, GraphQL. If in this model we become an expert in this, we'll start from step 0 in the next class, and we will master it. And after that, we will go towards e-commerce and then to serverless computing, extensive serverless computing. The thing is, we are loving, all 4 of us and also our Urdu team love to teach because we learn. We teach not to teach others. We teach to teach ourselves.
Yes.
And I believe this course is the only comprehensive course right now available in the world. This talks about all the different technologies, which combines them. There are a lot of content on the web, on YouTube and others, which might teach a single subject much better than us. But in a combined way, a comprehensive modern application development. So therefore, I want you to change in a few months' time your Upwork profile and your resume. Modern, I don't understand the words completely, modern full stack serverless application developer. Zeeshan, what did you say?
Modern Jamstack.
Or modern Jamstack. Now there is another thing. The thing is, I was thinking in myself, what am I? Because definitions are important. Am I just a Jamstack developer or a MERN stack developer? The point is, Jamstack is there, which is good enough. I cannot say that I propose MERN stack anymore. Because MERN stack implies monolithic applications. If there is some combination, if you go and check on Amazon, the new book that has come out from Amazon for their applications, they are calling it modern, I don't remember the exact name, full stack serverless.
Full stack serverless.
If you go, it basically teaches Amplify and rest of the stuff. Full stack serverless, because the thing is, MERN stack, assume that you are going to have an Express application on the backend. But right now, the technology we have, it is very counterproductive to have an Express server. MongoDB will be okay, but to have an Express server on the backend is not a very productive way of doing things because of the scalability issue. You want serverless, so therefore they are calling it full stack serverless. And we can call, therefore, this module, I've named it Jamstack Serverless.
Okay, sir. I will update my upper profile as well. Full stack serverless.
Now, these are the different names. We are, because Daniel, you understand, definition is important.
Yes, sir. 100%.
And for people who really understand what you are talking about, most of the people won't understand what you are talking about. But for people who understand, they understand. Even a single word conveys to them that you understand, and you can get a client because of that. The point is, full stack serverless concepts, which basically on the client side, but full stack, if you AWS is not recommending Gatsby or a single page app. They are neutral in this. They are saying, if you want to create, just to summarize the whole thing, if you have a client which comes and says, my friend developed for me an application, a dashboard which I can monitor all my salespersons. Of course, you don't need SEO. Therefore, what I would suggest is use Create React App, and on the server side, use serverless. To full stack serverless. If your client says, I need an e-commerce app, of course, then SEO is make or break. If you don't have SEO, what's the use of e-commerce website? So therefore, you will go with Gatsby. Now, in Gatsby, people might think that it is a static server, static site generation. So therefore, you cannot have user access, user authentication. It does client-side rendering also with equal ease, which we will learn in the next steps. So therefore, for e-commerce websites, I'll suggest Gatsby. For an internal application, which no SEO is required, Create React App will also. A lot of companies, for example, even Contentful, have two servers, two applications. One is the static site, and one which the main app, landing page, and all the website. The other one is the app, which basically is a single page app. So therefore, you can keep it also separate, build both of them separately, or you can, in using Gatsby, combine both of them. As we will go forward, you will define your own methodology and your own architecture. Everybody has their own style. But we have given you the basic theory. From the next class, we will start going into step 0 and going forward of this repository. Thank you, everyone, and bye-bye. See you guys.
Bye-bye.
Bye-bye.
Bye.